Okay, welcome to today's mini lecture. In today's class, what I'm going to actually do is go over 3 of the 6 problems that we had to do yesterday, which was on mole conversions. So you can see that I've drawn out my mole map down here and gave the relationships. So I have the mole to the volume. The relationship is 22.4 liters per 1 mole. I've got mole to particle, and the relationship is Avogadro's number, which is 6.02 times 10 to the 23rd particles per 1 mole. And then finally, I have the relationship between mass and moles. So this is going to be the molar mass, and we know that the molar mass is the number of grams that's in a compound per 1 mole. And that number of grams is going to be determined by the actual formula of that compound. So I would like to do question number 1, question number 3, and question number 5. So question number 1 reads, how many moles of magnesium is 3.101 times 10 to the 22nd atoms of magnesium chloride? So automatically you have to realize that that is 10 times 22. All right, so my computer did not pick up the subscript, so we'll just have to kind of work with that. So the first thing that we're going to have to do is we have to take magnesium chloride and we have to put the number of magnesium chloride, Mg, we have to figure out its formula. So I have Mg and Cl. We know that magnesium is a metal, chlorine is a nonmetal, so I have to do a crisscross. If I look right here, I see that magnesium is in my second column over, therefore it has a positive 2 oxidation number, and chlorine is way over here, and it's in my 7th one, and it has a minus 1 oxidation number. So I'm going to put minus 1 here. When I do my crisscross, I get my formula to be MgCl2. So now what I'm going to do is I'm going to write down what I'm given. I am given 3.01 times 10 to the 22nd, and that's going to be atoms of MgCl2. So I'm going to put that into my factor label box. So guys, always remember, every one of these conversion problems are always set up the same. You put down what you're given first, then we put the unit that we're looking for, and we are looking for moles, and then we're going to come back around and factor out atoms. So, what is the relationship between an atom and a mole? Well, we know that an atom is the word particle. So I'm going to put a little atom right there because atoms, molecules, and ionic formulas. Those are what represents the particles. So now, what is the relationship? Avogadro's number, 6.02 times 10 to the 23rd atoms, 6.02 times 10 to the 23rd atoms per 1 mole. So what that does is that's now going to leave me with the moles of MgCl2. Now, I always have someone who says, well, Mr. Vance, did we have to write the formula here? Because we didn't really use it in all of this. And the answer to this question is, no, you wouldn't have to do the formula, but I always do just so I know exactly what I'm doing. All right, so I'm going to type in, and that's going to be 3.10, and then second, double E, 22, and then I'm going to divide that by Avogadro's number, 6.02 times 10 to the 23rd. So when I put equals, I get 0.05 moles for my answer. All right, so that was the first one. What I'd like to do next is to go ahead and do question number 3. This one says, how many moles are in 28 grams of CO2? So I'm going to come back over here and I'm looking at mass to moles. So when I do this, I'm going to have to use the molar mass. I'm going to set this up the same way. What am I starting with? I am starting with 28 grams of CO2. So I'm going to put that in the factor label box. Then what am I looking for? Moles. What do I have to factor out? Grams. And what is the relationship between grams and moles? That is the molar mass. What is the molar mass? The molar mass is the number of grams in this specific formula. So I'm going to have CO2. So I'm going to put CO2. I know that that's going to be one carbon at 12.0. That's going to be 2 oxygens at 16.0, which is 32.0. So what is the molar mass? It is going to be 44 grams per 1 mole. So again, when I set this up on my computer, on my calculator, it's 28 divided by 44. That gives me a total of 0.636 moles of CO2. All right. Then the final one that I'd like to do says how many moles, and all of these were finding moles, but the other problems, 2, 4, and 6, are just the opposite. How many moles of argon atoms are present in 11.2 liters of argon at STP? Ding, 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 right there. STP, that usually means that we're using this relationship right here, volume to moles. And sure enough, how many moles are in, and that's liters, which is volume. So I'm just going to go through and write 11.2 liters of argon. Put that into my factor label box. Same way. Now what am I looking for? How many moles? Goes on the top. Factoring out liters. That goes on the bottom. What is the relationship? It's 22.4 liters per 1 mole. When I do that, my liters cancel out, leaving me with the moles of argon. So to solve for this, I just simply say 11.2 divided by 22.4, and that's going to be 0.5 moles. So I tried to set up some problems that were fairly simple as far as the math, but yet allowed you to see how to go about and do your conversions. So I hope this has helped. This is going to be the mini lecture. If you need me to help you with 2, 4, or 6, we can do that in our actual face-to-face on Google Meets. Hope that helped.